Welcome everyone. In this video we'll take a look at an A-level chemistry exam question involving ionic half equations. Details are in the description. I'll explain how to work out the formulae of negative ions that have a Roman numeral in their name. I'll also show you how to construct half equations and combine these half equations to give the full ionic equation. Let's get started. Here's the first part of the question. A student oxidized a solution of hydrochloric acid with a few drops of sodium chlorate 1 solution. The reaction mixture effervesced and turned pale green. The gas formed bleached universal indicator paper. Write a half equation for the oxidation of chloride ions. Chloride ions, Cl-, must appear on the left-hand side of the half equation. There are clues in the question about the product. When chlorine is dissolved in water, it will turn pale green. Chlorine gas will also bleach universal indicator paper. Therefore, chloride ions are oxidized to form chlorine molecules, so Cl2 appears on the right-hand side of the half equation. Oxidation can be described in terms of loss of electrons. Electrons must appear on the right-hand side of the half equation. Next, we have to balance. First, we must balance for chlorine. 2 chloride ions will produce 1 chlorine molecule. Finally, we must balance for charge with electrons. There is a total charge of -2 on both sides of the half equation now, and this part of the question is complete. Here's the next part of the question. Write a half equation for the reduction of chlorate 1 ions to chlorine in acidic conditions. First of all, we have to work out the formula for chlorate 1 ions. Sodium is in group 1, sodium ions will have a charge of +1. From this, we can tell that chlorate 1 ions must have a charge of -1. The Roman numeral 1 tells us that chlorine has an oxidation state of +1 in this ion. Ions that end in ate, ATE, contain oxygen. From the rules and guides for assigning oxidation states, we know that oxygen must have an oxidation state of -2 in chlorate ions. We can put all of these facts together to work out the formula of the chlorate 1 ion. Now we can start to construct the half equation. The chlorate 1 ion is shown on the left. I've put the oxidation states of chlorine and oxygen in red above the ion. We are told in the question that chlorate ions are reduced to form chlorine, so Cl2 must appear as a product on the right. There must be 2 chlorate ions on the left so that the equation is balanced for chlorine. Water molecules H2O and protons H+, are present under aqueous acidic conditions. Water is used to balance for oxygen. Protons are used to balance for hydrogen. In the final step, the half equation must be balanced for charge. The overall charge on the right of this half equation is 0. 2 electrons are added to the left-hand side. Reduction is gain of electrons. If you find that electrons appear on the right of a reduction half equation, go back and check your working out. This part of the question is now complete. Here's the final part of the question that we'll look at in this video. Write an overall equation for the redox reaction of chlorate 1 ions with hydrochloric acid. We will need to use the half equations from earlier to write the overall equation. These are shown in red. Before half equations are combined to construct the overall ionic equation, they must be balanced for electron transfer. The electrons lost in the oxidation half equation are the same electrons gained in the reduction half equation. Electrons never appear in the overall ionic equation. The oxidation half equation shows that 2 electrons are lost. The reduction half equation shows that 2 electrons are gained. In this case, we just need to combine the half equations and cancel. The next line shows all the reactants added together on the left and all the products on the right. Electrons cancel on the left and right. We can also combine the chlorine molecules on the right. The final answer is given here in blue. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.